Okay, so we're going to sketch the graph of y equals x squared minus 2. So first we're going to start off and we're going to make ourselves a little axes. We're going to label y and x. Okay, and so we want to do this y equals x squared minus 2. Many ways you can go about it. The way I normally like to try to figure out how to graph something, um, you know, this one can be done in a bunch of different ways very easily. But one way I like to do it is to find the x and y intercepts. So if I was to find the x-intercepts, what we're looking for is when y equals 0, because that's the line. Okay, so um, we go back to our original equation and we plug that stuff in. So we're going to have 0 equals x squared minus 2. Okay, and so based on this, we want to solve for x and figure out when that is. So the first thing we're going to need to do to find what x is based on our handy dandy PEMDAS chart. Remember, we go backwards down this chart to solve. So we start off and we actually see we have subtraction, so we're going to add 2 to each side. And you end up with 2 equals x squared. Then the next thing we have is an exponent, so we undo that. So we take the square root of both sides. Now it's very important to realize that when you take the square root, when you're solving, you have to include both the positive and negative options there. So you're going to end up with x equals the positive and negative square root of 2. Okay, so places where we're going to plot this, so we're going to have some number here, which is, this is going to be um, the square root of 2 comma 0, and this is going to be the negative square root of 2 comma 0. Okay, then lastly we're going to try to find the y-intercept. The y-intercept over here is when x equals 0. So we go back and we write our equation out, and we see that we're going to have y equals 0 squared minus 2. Very easy to see here that y is going to be negative 2. So we've got another point all the way down here, which is going to be at 0, negative 2. Okay, and we go ahead and just connect the dots. And we know that this is a parabola because it's x squared, so you know basically it's going to have that general U shape. And here we go. And you can add in other marks and stuff, but this gives you a general idea of how you can go about graphing it, and just generally knowing what most graphs look like is important. All right, so our next example here is to find the x and y intercepts of the graph x cubed minus 4x. Okay, so we don't even have to graph it. We just need to find those points. Okay, so it's important to read the question. We don't need to graph it at all. So in order to find our x-intercepts, again, we need to find when y is 0. So we go and we write our equation out. So we're going to have 0 equals x cubed minus 4x. Now, this problem can be done. This is if you look at it, it's a little problematic because we got this cube. Cubes are really difficult to deal with a lot of times, especially when you have multiple terms involving x. But in this case, it's not so bad. This would be a problem that you would generally need to use a calculator if we had something like a plus 2 on the end. But because both of these terms have an x in them, we can factor it out and make things very easy on ourselves. So we go here and we're going to get 0 equals. We see again that we both have an x in both terms, so we factor that out. Then we see what is left. So when we take an x away from x cubed, we are left with x squared. When we take an x away from negative 4x, okay, what's left is the negative 4. Okay, so each of these right here, because we have two things multiplied by each other to make 0, we know that either can be 0. So from this point, we know that x could be 0, or x squared minus 4 is 0. So we just need to figure out this part over here. So this is a slam dunk. This right here is an intercept. So now we need to figure out the other side. So again, we do our reverse PEMDAS like in the previous example. We add 4 over. You're going to get x squared equals 4. And kind of like the last example, remember, don't forget the positive and negative. We take the square root of both sides. So we're going to get x equals positive or negative 2. So these are our x-intercepts. So we actually have 3, which we could have as many as 3 because this is a cube. Then we're going to find our y-intercepts. So for y-intercepts, we set x equal to 0. Well, this happens to be very easy for us because we're going to have y equals 0 cubed minus 4 times 0, which is just 0. So that is our y-intercept, and we are finished with this problem. So the important thing is to just plug it in. This side was a little problematic, but our main strategy here is to factor. Factoring is always the way to go. For example 3, it says show that the graph of y equals 2x cubed minus x is symmetric with respect to the origin. If you remember from the previous concept video, respect to the origin means that if I have a point x, y, that implies that I will have the point negative x, negative y. So that's what we're looking for. So we already have a relationship that says that y equals 2x cubed minus x. So what this means is that if I plug in a negative x into this right here, instead of x, I use a negative x in place of these, that I will get a negative y out. And if that occurs, then I have symmetry with respect to the origin. So what I'm going to do here is kind of take this second part, but rewrite it with a negative x. Okay, so I'm going to have 2, or I'm going to have, excuse me, I'm going to have 2 times negative x cubed minus negative x. Okay, and so from this, I need to simplify. So if I cube a negative x, what happens? So I've got a negative x times a negative x times a negative x, which negative x times negative x is going to actually end up being a positive x squared. And if I multiply that by this negative x, which I brought down, I end up with negative x cubed. So I actually end up with the opposite there. So this ends up being 2 times negative x cubed. If I subtract a negative, I end up with a positive. So I get a positive x. If I simplify this even further, 2 times negative x cubed, I always want to pull the negative out front. So I get a negative 2x cubed plus x, which when I compare that to 2x cubed minus x, these are exact opposites of each other. Okay, you can see that this has changed to a negative, this has changed to a positive. These are exact opposites. So what I can actually say is that this equals negative y, which was the result that I was looking for to begin with. You can confirm this by, if I were to multiply each of these by negative 1, I would get negative 1 times negative y is y, and negative 1 times this side, negative 1 times this, would give me a 2x cubed, and negative 1 times this would give me a negative x. So this result, the fact that these two match, now, because each of these is negative, tells me that this has respect with the origin. And finally, our last example, find all the points of intersection of the graphs x cubed minus y equals 3 and x minus y equals 1. So what we need to do here is we need to control for one variable. So we need to solve each equation for one particular variable, and then we can use that to set them equal to each other, so kind of remove them. In each case, this x cubed would be hard to get down to an x. It'd be a little bit of a pain. So we're going to make sure we control for y. So I want to get y by itself. In order to do that, I'm going to add it to both sides. So you get x cubed equals 3 plus y. And I'm going to subtract 3 from both sides and get x cubed minus 3 equals y. On this side, I'm going to add y to both sides. Get x equals 1 plus y. Subtract 1 from both sides. Get x minus 1 equals y. And then what I'm going to do is set them equal to each other. When I do that, because this is a y and this is a y, we're describing when they intersect, so they have to share the same thing. So if they're sharing the same y point, then the x's would have to be the same as well. So I can just collide those two together. So what I can say, if I want to know where they meet, then it would be where x cubed minus 3 meets x minus 1. Now, when I go through here, I'm going to get it all on one side and set it equal to 0. That's going to be my goal. So I'm going to subtract x and add 1 from each side. And I'm going to get x cubed minus x minus 2 equals 0. And so I want to figure out where that is going to match. Now this, like the example I told you earlier in number 1, or excuse me, not number 1, number 2, because we're adding on to the end, this becomes a much bigger pain. And so what I need to do is use the calculator. I don't have my calculator on me right now. Fantastic. All right, so hold on, let me pause. Okay, so I have grabbed my calculator and went through, and I have found that there is only one value that satisfies this, and that is x equals about 1.52. Okay, so again, this is one of those times where you can't just do it all by hand. Sometimes you can. You know, if it's an x squared, you could do the quadratic formula, you could factor. If it was just a single x, you could obviously solve very easily. Anytime there's a cube, more x's, and a constant, it's generally bad news. And so that's generally when you're going to have to reach for your calculator, unless you're like the Rain Man. But in this case, this is our single lone answer. So that is the only place that those graphs intersect.